All right, we're going to continue from where we left off yesterday. Example 8. Graph this function. I see a new student. Are you in this class?
Yes.
This is Calculus 1. No, Algebra.
Okay.
And I guess I have stuff for you. Here you go. These are a lot of the notes and the examples that we're going to do in class. All right. So remember what form this example was, this equation. Y equals mx plus b. Whenever you solve for y, okay, this has got a name. We're going to talk about this later on today, this form of this equation. Whatever is in front of the x, the sign and the number, whatever's in front of x, is your what? Is your slope. And then whatever is after the x, the sign and the number, is your what? Y-intercept. Very good. So when we graph our picture, how do we graph a function or an equation in this form? Here are the steps. First step, plot B, the y-intercept. So our y-intercept is what? 0, 4, which is right there. From that point, follow the slope, m. So what is our slope? Yeah, -2 over 3. Even though the negative's in front, never goes to the bottom, always goes on top. So what does -2 mean? Go down 2 spaces, and then 3 to the right. 1, 2, 3, and then plot a point there. Then connect the dots. Pretty easy. That's pretty much all there is for graphing equations. Let's look at some word problems now. Where did I have? Well, here's some applications for slopes. In the real world, how many of y'all ever notice highway turns? All of them are angled. Why? For 2 reasons. Why? Water. In case of rain, what happens if it's tilted? What happens to the water? It goes off. If it was flat, it would just puddle there. And you're going 70, 80 miles an hour and you hydroplane, you fly right off. And also because of that, you can go faster without worrying about sliding off from friction. If you have bad tires, you won't slide off because now your car is now pushing against the ground. If you ever been to the Texas Motor Speedway, that's a place you got to go see. That the turn that they have over there is something like this because the cars are going over 200 miles an hour. You have to make sure that the angle is hard enough so the cars don't go flying off the turns. So if you haven't noticed that, do that. Look, next time you go on the highway, feel the turns and you see that your car is actually turning sideways. In construction processes, when you hear the word grade, how many of you have ever been to Colorado or any state that has a mountain? You always hear of grades. That's the slant of the highway. In other words, how high does it go? How far does it go? A grade is the slant of the path. I don't want to say road because it also works with what do you call that? Ramps going outside of buildings for wheelchairs. So whenever you talk about grade, you're talking about the slope. So in our example, the US government stated that the roads have to have a certain degree of tilt. And it varies what that is. So, for example, what this one says is you can have a 2%, 4%, 7%, or even up to 18, 19. If you ever traveled in northern New Mexico or southern Colorado, they have some of them have no limits on the speed limit. So the roads can be really steep there. Or if you look at, well, here you have the formula for the slope. When we talk about the grade and slope, we talked about rise over run in this class. And so it's the vertical change over horizontal change. If the slope is positive, what does that mean? It's going up from left to right. If the slope is negative, it's going down. Can a road be both? Yes, depending on where you're going. If you're going from the bottom of the mountain to the top of the mountain, it's an increase. If you go from the top of the mountain to the bottom of the mountain, it's a decrease. Case in point, I love traveling. There's a place called Donner Pass between Nevada and California, and it's always snowing up there. If you're going up, you can't get to the top because of the snow, the ice, and your wheels just spin, and you just go backwards. That's not bad. But when you're going from the top down, guess what happens? Once you lose traction, you can't stop, you can't turn, you can't do anything. So you just go wherever that road takes you. So how do you think they fix that? At the very top, there's a sign that says you cannot go any further unless you have snow chains. Who carries snow chains in their car? But do you think you could buy some up there? Yes. They're smart because these are all vacationers. So they sell them up there for like $40, $50 a piece. And they'll put them on for you also. Guess what they do in the bottom where the snow stops? Well, you can't have chains on your tires anymore. You got to take them off. Guess what they have on the bottom? They have people down there said, we'll take them off for you. And they'll ask you, do you want to keep these or do you want to keep them with you? Well, who's going to take them back with you from if you live somewhere that doesn't have chains or snow? You don't need them. If you live in Southern California, you don't need chains anymore. So keep them. So what do you think they do? They go back, they take it back to the top of the mountain, sell it again. They do that all year round. So it's funny, but it's expensive. A sport that deals with grades, downhill skiing. The steeper the mountain, the faster you go, which is the fun part and the dangerous part. Just think about it. When you fall down, do you just stop right there? No, you keep on rolling and rolling and rolling, and your skis come off, and you keep on rolling and rolling. And after you stop, guess what? You're down here, and your skis are up there. So now you have to go all the way back up there and get them. So that's one thing you look at is um, look at mountains. Humans are innate animals. Is we'll look for the most dangerous things to do, and we'll play there. So here's an example: curb ramps for handicapped persons, wheelchairs. Curb ramps present independent access sidewalks to those in wheelchairs. Guidelines for the grade of the curb of the ramp suggested a grade between 5.9 and 8.3%. What is eight? What is a percent? It's the grade, but what exactly is a percent? Again, remember, mathematics is a language. We talk about percent. Per means what? No, not per. Per means if you have $2 per child. If you ever go someplace with $2 per child entrance fee, so that means each one of those. Cent is Latin for 100. So the percent symbol simply means some number over 100. Like 10%. Instead of that percent symbol being there, change the percent symbol to 1 over 100. Now we have 1 over 10, which is equal to 0.1. So the rule of dividing by zeros, whenever you have a zero on the bottom, all that means is move the decimal place over 1 to the left for as many zeros you have. So 3 over 100 would be what? Yeah, here's a decimal over here, so you move it 2 spaces. So you have 0.03, which this is the same thing as 3%. So that's what we'll talk about that. Almost 80%, 70% of your word problems will always have some sort of percent question in there. And what it also means when you calculate these, it's always part over total times 100. You don't have to worry about this part, but it's always part over total. So it's like a slope. All right, so let's look back. Let's look at our example here again. So the U.S. guidelines between 5.9 and 8.3. Federal law states that the vertical rise of 1 feet requires a horizontal run of 12 feet. What does that mean? What it says is for every 1 foot that it goes up, it has to go out 12 feet. So the rise over run. One divided by 12. 1 divided by 12 is 0.08333. Did we see that number before? What would that be in decimal, in percent? In percent, you move it to the space. Remember I said percent is part over total times 100. So it's going to be 8.3%. And remember, we saw that before. We saw that before, right? Where is that? Right here, 8.3%. So the maximum for every 1 foot up, you have to go 12 feet out. Contractors do the same thing for your roof. They have similar requirements. Just think about it. Would you want a flat roof? Nope. Although they do make buildings with flat roofs. A lot of large high rises have flat roofs, and they have to go there all the time and put pitch and tar up there all the time to seal up all the holes. So this question, it's asking us, find the grade of the curve of the picture showing. So what it's saying is, if the rise is 3 inches and the run is 42 inches, what is the grade? So it's 3 inches. So the grade is 3 inches over 42, which is going to be, look at this, 3 divided by 42, 0.071428. Now, the question is, how many decimal places do you want to have? When we convert this to percent, we move the decimal 2 to the right. Because remember, part over total times 100. The 100 means you move the decimal 2 spaces. So this becomes 0 or 7.1428%. It's very difficult to make it that accurate. So typically what we do, we'll just stop on some cases is 1 decimal place. Which now brings us to a point of rounding rules. If I had 7.148 and I want to round it to 1 decimal place, look at the next number. Since you're rounding to this place, look at the next number. If it's between 0 and 4, drop everything after that 1. Then it becomes 7.1. Let's say I want to round it to 2 decimal places. So I have 7.1. Now, since I'm rounding 2 decimal places, I look at the next number, the third number. If it's between 5 and 9, then add 1 to your number. In other words, the number I'm looking at is this one. Since I'm rounding in 2 decimal places, I look at the third number. It's between 5 and 9, so I round that one up. Those are the rounding rules. So it's whatever number of decimals you want to be accurate to, look at the next one. If it's between 0 and 4, just drop them. If it's between 5 and 9, increase that one up by 1. Any questions so far? All right, let's look at another example. The average rate of change. Instead of saying slope, which doesn't sound too businessy, they call it average rate of change. If you think about it, average rate of change. Let's look at those words. What is an average? How do you calculate an average? How many you have? Yes. So you take how many numbers you have and divide it by how many numbers you have. It works the same in slopes. Because remember, we have y2 minus y1. Those are the number of items that you have, the ones you're looking at, over how many you have. Think about it. If you are a business, this is the stock on hand that you have, X1, X2, X3, and so on and so forth. And here we can look at our sales. So the average number of sales, which are the Y values, Y1, Y2, it's the number of them divided by how many you have on hand. So it's an average of number of sales. Rate of change. What do we call? Why is it called a rate of change? It's what? Escalation. Yes, it's or a declination or escalation. But yeah, but we call it, the reason we call it a rate of change is because from one point to the next, it's going up. From one point to the next, it's going, in this case, it's going up. So it is a rate of change. How fast is it going up, or how fast is it going down? It doesn't have to be always positive. If it's positive, it's up here. If it's negative, it's going down. Y'all ever heard the supply-demand curve? Let's say the supply you have is this stuff. This is your supply. Supply is how many items you have in your storeroom, in your shelves. Think of Christmas time. Tickle Me Elmo. I don't know if you remember when that was a big deal. Okay, what's the one you guys remember recently? What's a big thing that everybody's wondering about? The Stanley Cups. Remember those? They're just cups. They're no different than any other cup out there, a Yeti cup or anything like that. It's just that Stanley, somebody made it popular, some actor or athlete, and everybody has to have it. So there was tons of them on the shelf before anybody knew what they were. Nobody would buy them. This is the demand. Eventually, it made it to TikTok or YouTube or some social media, and all of a sudden people will say, ooh, this person's got it, so I better get it. I don't know why. They get it for free. You have to pay for yours. So all of a sudden what happens? The supply starts going down because everybody's buying them up. Once people start buying them, the demand goes up. Eventually you get to the point of equilibrium. That's when everything is in balance. You have as much as people want. Everybody's happy. Who's happy before that? Who's happy before that? The demand people. No, the people who are in demand. The consumers. Because I want to go buy it. Is it going to be on the shelf? Yes. So it's there. The department store is not happy because they have all this stuff on in their shelves that nobody's buying. The more stuff you have on a shelf, the more money you're losing because you still have to pay for it. But then once equilibrium is finished, now who's happy? The department store is happy because you just bought everything they had. They just made a lot of money. You're not happy because you want to buy it and there's nothing out there. What happens to the price? It goes up. Because whenever supply outweighs demand, the price shoots up. Artwork. Bless you. A Michelangelo painting. Is it cheap or expensive? Super expensive. Why? Because what's the supply of Michelangelo paintings? It's next to zero. How many people want them? A lot of millionaires and billionaires, but they can't because there's nothing out there. As soon as one of them goes on sale, it skyrockets. But if you want to buy a Wrigley's gum at the department store, at the food store, are you going to pay $1 million for it? No, because the supply of those are billion to one. They're there. So this is what we call rates of change. So in our example, the number of people participating in the federal food supplemental nutrition assistance program has increased from 17.2 million in 2000 to 47.6 million in 2013. The following graph shows that. Find the average rate of change of the people using food stamps from 2001 to 2013. So in 2001, how many people were there? So in 2001, it's about the same, hasn't changed much. So we're looking at 17.2 million. And then in 2013, how many people are using it? In 2013, it's here, it goes up to 47.6. Let me go back over there. Sorry. But again, you have this in your packet, so you don't need to hold me. You notice whenever you deal with XY graphs, time is always the x-axis. Time is always the x-axis because whenever you look at increasing or decreasing, you always read left to right. Time never stops. Time never goes backwards. So time is always on the x-axis. And whatever you're looking at, in this case, millions of people using the program, that goes on the vertical axis. Whatever changes over time goes on the vertical axis. How many things are based on time? If you think about it, how did you get here from home? You drove, you walked, you rode a bike. You had some sort of speed, miles per hour, feet per second. So almost everything we deal with nowadays works with time. Bless you. So since time deals with the x values, the number of people are the y values. Here we have x1, y1, x2, y2. Because our first time period, 2001, it corresponds to 17.2. On our second time period, it corresponds to 47.6. So the average rate of change is nothing more than the slope. So our slope formula is y2 minus y1, x2 minus x1. So y2 is 47.6 minus y1 which is 17.2. X2 is 2013 minus X1 is 2001. So the difference between 47.6 and 17.2 is, subtract those, 30.4. 2013 minus 2001 is 12. So we do the calculations. 30.4 divided by 12. It equals 2.533. Now, notice how the 3 goes on forever? Instead of writing 33333, since it's the same number after that, I just put a bar over that one. Oops, let me show you. Because the 3's happen forever, instead of writing all the 3's, that bar tells me that this number is repeated infinitely. So what does this tell us? So what does this number tell us? But what does it tell us? Yes, you're telling me what it finds, but what does it tell us? Yes, there's a 2.5 million people per year increase. Since it's positive, it's an increase. That's what that number tells us. All you guys told me, you just defined what it was. It's average rate of change. I know that. That's what we're looking for. But what does it mean? It means that there's 2.5 million people per year increase each year. Oil imports. Increase oil production in the United States has resulted in a decrease of import of crude oil from around the rest of the world. The total number of barrels, this is example 5, the total number of barrels imported in 2008 was 3,590,000 barrels. The number had decreased to 2,810,000 barrels in 2013. What is the average rate of change in crude oil imports from 2008 to 2013? Again, time is X, and what you're looking at is your Y values. So which one's X1? The 2008, because it has to be the first one. So X1 is 2008, X2 is 2013. Since this one corresponds, that's got to be Y1, and this has to be Y2. So the average rate of change is the slope, which is Y2 minus Y1 over X2 minus X1. So X2 or Y2 is 2,810,000 minus 3,590,000 over 2013 minus 2008. Let's see which next we're going to do. Oh, the last one. Oh, good. So let's do these calculations. We have 2,819,000 or 208,10,000 minus 3,590. That equals negative 780,000. Twenty 13 minus 28 is 5. So we have this number, we divide it by 5. Our average rate of change is negative 156,000. So what does that mean? What decreases? The number of barrels, not just oil. Because remember, you have to use what units we're dealing with. Since these are number of barrels, this is a decrease of 156,000 barrels per year for each year on this in that time period. So far, so good. I don't know why they put this next part here, because the next topic we're going to talk about has to do with slopes and the equations of lines. Well, I won't talk about this one. So that's it for that section. All right, so we just get ready for the next section.